Hey everybody, thank you so much for coming to my talk. I never thought in a million years I'd be speaking internationally, so thank you so much. I really appreciate being here. Today I'm going to be speaking about how to extend Spinnaker with GitOps. So a little bit about myself. My name is Joel Vasalo. I'm the manager of Cloud DevOps at Redbox. There's my Twitter and my GitHub. And my Gmail. For those of you who may not know, I've been in the Spinnaker community for 3 years now. And even before that, we used a tool called Asgard. It was kind of like the predecessor to Spinnaker. If you used Asgard, it was a fun ride, especially in the open source world. So before I start, let's take a journey through modern CI/CD, right? Common delivery patterns. So, your boss comes up to you and says, hey, we want to move and, do this DevOps thing. So how do we do this? First thing, got to find an environment. Where are you going to run this? Do you have a data center? Do you ever have OpenStack? Do you run Kubernetes? Do you need Amazon? You want Google? At the end of the day, the biggest thing to take away is pick one, start small, and grow from there. So hopefully you all picked one. Great. What are you going to do for source control? You can use GitHub, you can use GitLab, Bitbucket, Azure DevOps now as well has its own platform. Again, details, pick one, go from there. Continuous integration time. What are you going to do to build code? You use GitLab CI, Travis CI, Jenkins. Where are you going to store that code? You're going to put it in Artifactory? Are you going to use some Docker registries? Are you going to use Nexus? Again, all details and every organization is going to be different. So find the one that works for you and your developers and go from there. And finally, continuous delivery. Again, GitLab, Jenkins, they're great tools. They can be made to deliver code. But I'm a little biased, and that's why Spinnaker is so big. I like Spinnaker a lot. As you can tell, no, maybe the shirt kind of gave that away too. We'll go over that too. So you picked everything, right? Everything's great. You're in the cloud. You have your Git source control. You have builds executing every hour, and you have code being pushed out every few days or every day or so, right? Everything's great. So why am I here talking to you folks? Let's examine. If everything kind of worked, you should hopefully be trending your deployments upwards. You're able to release much easier, automated testing. And since you have that tight cycle, you're able to then have a more productive and open development. You should also see more collaboration building into the organization. And then hopefully that translates into releases, what the product and the company actually cares about. Are we able to deliver features faster to our customers, right? So what's wrong? Again, I'm just telling you good things. First off, there was about 200 and some odd combinations of tools that I just presented on the last slide. How are you connecting all those tools together? Are they done manually? Have you created those Jenkins jobs manually? Did you set up Artifactory manually? What about if something goes down and you lose all that data, how do you recover? You don't have a way to reproduce that. Traceability, again, how do you track changes to the cloud? Do you just give everyone admin and just give everyone admin keys and you're good to go, right? It's obviously the easiest, but is that the best thing when stuff really happens, right? You hear things like on the news where S3 buckets are compromised and all this stuff, right? So you want to make sure you have traceability for a good reason. And ultimately, observability. Stuff going down and breaking, you want to know, get an alarm. Hey, the website's down. Instead of your customers calling customer service saying, hey, the website's down. Because that customer may no longer be a customer if you can't recover in time, right? All right, so this is where a concept called GitOps can come into play. So what's GitOps? It's essentially the concepts of using a source control repository for everything in your application's lifecycle. Very commonly, developers use Git in their day-to-day to commit source code and deliver that to the world and ultimately get that built. But then you have to step back and ask, do I have my build process in source control? Can I define how I build my code? Can I define the metrics and the way my code needs to operate in production? right? So those are some questions. So GitOps is essentially going down the stack all the way down to declaring how your code is built, how your code is configured, and ultimately how it's deployed. So what does this look like? I just spent a lot of time talking. Really, at its basic is you have your source control, a Git repository. You have an operator. Again, mysterious. That's not a tool. There's not a tool you can buy that has a yellow, well, maybe there is, but that's not a tool that ultimately takes something in source control, does something to it, and delivers it to somewhere else. So whether it be a Kubernetes cluster, updating your application configuration files, or being delivered to a cloud provider, like updating an S3 bucket policy or something. So what are some of the advantages of going down the stack, right? And ultimately version controlling everything. What do you know? It works fine. I can go in the GUI, click, and it's all good. First off, having everything declared means you can write common tooling, right? If everything is defined in a YAML or a JSON, again, I'm not going to have that battle. I don't care if it's YAML or JSON. Define it somehow. You can onboard developers easier, right? You can have a way to define infrastructure that's common so everybody can just specify, hey, I need 3 servers. I need to deploy to using Jenkins. I need to, update an S3 bucket, right? The best thing, too, about it is having it in Git reduces cognitive load. Ask yourself the question, what are developers most likely in all day? An IDE and Git, right? Do you really want to have to switch your brain and say, okay, I committed my code. Now I'm going to go to this website. Oh, wait, hang on. I have to go to Okta. Okay, log in. I'm in now. I got to click the button. Okay, I got to click the Jenkins job. Okay, now that's an Artifactory. Okay, I got to go to Artifactory. Then when you want to get back to coding and fix that bug, you have to kind of reset your mind. But if you can operate within the concepts of a Git repository, it kind of makes things a little bit fluid. And ultimately, by writing common tooling, you get the ability to automate. And automation means you can reduce error, human error, right? Just this week, I've copied a container's ID wrong, and I deployed version 1 instead of version 18, right? So potentially reducing that. Traceability. What is Git good at? It's good at tracking changes. So if you can commit your changes, you'll have a historical record of all those changes throughout the life cycle. And ultimately, you can introduce audit trails. Observable tooling. You get faster deployments because you're able to see those infrastructure changes that I've been alluding to. And ultimately, it's easier disaster recovery. No longer is the question of, how big was that server? Was it 2 gigs, 3 gigs? You defined it all. It's just a matter of rebuilding, running your scripts against your code, and you're back up and running. Hopefully. Not always the case. GitOps isn't new, though. I mean, there's a buzzword going around. It's called GitOps. What does this mean, right? Think about it. Source control today, it's already in Git or in some sort of repository out there. Most times, the runtime configuration, your application settings, is already in the repository, right? Maybe not the secrets, but majority of it. The current trend today you hear around the world is infrastructure as code, right? You define your infrastructure, you declare what you want in code. But then I always challenge that and say, what about the build process, right? So you have your infrastructure done, you have your code done, but how do you make that code that goes into that infrastructure? Good question. So really for me, the biggest thing I always like to say is that any tooling that you write has 3 things in mind: reproducibility, traceability, and observability. 3 things. So reproducibility, what do I mean by reproducibility? Take a look at some of the best forms of reproducible artifacts today. Docker files, Jenkins files, Ansible definitions, Ansible roles. At the end of the day, tell yourself, if it can be described, it can be automated, right? How many workers do you need? How many servers do you want? What port should be open? What should be locked down? What should be wide open? By declaring it all, you can go to a single source of truth, get that, and use tooling to deliver your software out there. And then I guess the last thing too is that if it's well-defined, it's automated, the most important thing is it can be rebuilt. Rebuilding your stuff in the event of a disaster recovery greatly reduces that planning. So commonly, like when doing data center things, you're thinking like, well, how are we going to migrate traffic over? What are resources do we need? What networking policies do we need? Great, it's all defined for you. There's no question about it, because every time you commit, it makes that change for you and delivers that change for you. Traceability. So yeah, I said earlier, how do we trace who made the change? Git affords us that as well. Commonly in the land of Git, and developers know this, you pull requests. You submit a pull request. Hey, Susie, please review my pull request. I'm proposing a change to make this port wide open, right? You capture the diffs. Good. You have an open discussion. Most common tools today have, I don't think this is a good idea, right? Or whatever. You collect approvals. Tools have a yes or no. I don't think this is a good idea. I think this is a great idea. And ultimately, you track your changes. How did this get into the master branch in Git? So-and-so click the button at 622, and that's why the world is the way it is, the infrastructure. The best part is, you run into issues. Say I made port 80 wide open, and then a bunch of hackers started attacking us. Guess what? There's a nice revert button usually in the Git UI too to get that reverted back, and guess what? You're locked down. When an auditor comes around and says, hey, I heard developers are committing their files. How do we know when things are changing? Audit time. Show them the Git repository. Here's everything. Tell me what's wrong. What can I improve, right? No more hiding how things are configured, using your Git repository as your single source of truth. Observability. So with the concepts of GitOps, what you're doing is you're defining something in Git and comparing that against something that's out in the world, in the AWS, in Google Cloud, wherever it may be. Eventually, hopefully with the practices of GitOps, you're able to take that desired state in Git and promote those changes through some operator, as I alluded to earlier, and make those changes within your cloud environment or your data center, or wherever it may be. Observability is really important because it gives you things of metrics and monitoring. You can do canary analysis and ultimately have alerting. So for example, Spinnaker alerts every time a deploy happens. There's no longer a question as to when things change. Spinnaker can alert. In this case, Spinnaker alerted when things are broken, when the build failed, right? Getting those alerts in your Slack channel where you're communicating with your team every day are invaluable, right? So observing your changes. So this is a really good quote by Alexis Richardson from Weaveworks. The original concepts of DevOps were to just version control your config. What is the property file? Database URL, database password. With GitOps, we're extending that by version controlling everything, the whole thing, or as much as can be. What can be described can be automated. So I've been talking a lot about this, and you're probably like, where's the tool? Where's GitOps? How do I install GitOps? I can't, right? It's not a single tool, it's a practice, and ultimately a process, right? You have to practice this in your culture, in your work environment. Personally, I think that it's the process of empowering developers to control their entire application through a familiar workflow. Right now at Redbox, developers are empowered to deliver code on their own. There's no operations team to deploy their code. Me being on the DevOps team and my team, we build a paved road. Developers are more than welcome to drive it, but if they go off of it, they're kind of on their own. But we give them a safe way with nice guardrails to deploy code. This could be easily summed up in the words of Steve Ballmer as developers, 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 developers. Make everything about your developers. Give developers the power to make change in the organization. Okay, that was pretty good. The biggest thing too is abstract away these random tools, right? If you're using Kubernetes, kube control, kube cuddle, right? Don't just give someone, say, hey, run Terraform apply, right? Don't just give someone Boto 3 and say AWS S3 create bucket, update policy, right? Those are prone things. Those are operations that are done one time and usually are forgot, lost. Write compelling tooling around that. Really, at the end of the day, make it as simple as submitting, reviewing, and hitting merge pull requests. So I alluded to it earlier. I said that at Redbox we have empower our developers. What do we mean by that? So we leverage the concepts of GitOps to enable developers to make change without getting buried in the details. The biggest thing is to eliminate the steps earlier, like for example, kube control and Terraform apply and S3 bucket create, not because the developers can't understand the process. There's no question about it. Developers are very smart. They can learn tools, right, every day. Developers are building great things, but they shouldn't need to. Ask yourselves, are developers going to be building S3 buckets? Is that really what we're looking for them? Or are we looking for them to deliver that great feature so our customer can come back to our portal and use that service again? Or chase down those bugs and solve that problem, right? So, and then it's really building on the concepts of no ops, right? Give your developers something they're familiar with. If I said, hey, developers, clone this repository down and make the changes in these property files, commit it back to source, and do your standard code review process on it, and your changes will be promoted. Most likely, most of the time, generally speaking, it's a common process. Oh, cool, it's defined, it's declared, I got it, no problem. As a developer, you probably have one flow in mind. Everything else is just noise, right? This is a great quote when Kelsey Hightower was, I think it was KubeCon or one of the Google conferences. He was asking, it's like, all right, cool, you installed Kubernetes, right? Now you just give your developers YAML, right? Everyone, developers, how many people want to write YAML files? No developer raised their hands. So you go, C operations people, they don't care. So you don't want to give developers just raw YAMLs. Like, all right, fine, here, run Kubernetes, do YAML files. Give them compelling tooling to make it easy for them. So I spent a lot of time talking around the practice and the thought, and you're like, where's the technical details? This is a technical talk, right? So, all right, let's talk about GitOps in action, how this looks. So again, to iterate, some source repository, some operator, and a way to deliver that, right? Another way, common, if you want, you could split off the application in the config repo. That's also another common practice. There's not much into it. You can put all the configs in one repo or split them into two. It's really what works for you and your organization. So I alluded to it earlier. Today, we're all about infrastructure as code. That's kind of what the industry is kind of moving around of. So with infrastructure as code, some of you may have seen tools like Terraform, Ansible, Puppet. There's CloudFormation. There's Deployment Manager for Google Cloud. Various tools. Again, tool overload. Pick one. In my case, I'm picking Terraform. Why? Because that's the one I know. So how does Terraform work? I know a lot of folks may not be familiar with it. This is a Spinnaker talk. Basically, you declare what you want. There's a security group saying allow all. I'm going to allow all the traffic. I do a command such as Terraform plan, and it gives me back some, hey, you may be changing this file, right? You may be changing this environment. If you like it, you hit Terraform apply. The operator goes out, makes the changes, and you get a state file. And it kind of tracks your history of changes in this Terraform state file. It's great, but there's challenges with this. By default, Terraform ships with a local state file, meaning that if Susie runs Terraform and Joel runs Terraform, they could be potentially two different planets of configuration. Not a problem until the next change comes in and they keep getting further. And they keep getting further. And then comes the big one where when John tries to make a change on Susie's, the whole thing falls apart. So that's one of the big downsides of it. Multiple operators, as I'm alluding to, you have two people making changes now. That's a small team. Still not a bad thing. A team that I came from had about 9 engineers making changes at any given time. Update the firewall, update the server, update this. Everyone making changes means now there's 9 different states of the world of how the company may be defined. Scary. And then ultimately, the last one is Git can have secret files. Like when you start doing you could store secrets into that file, and it's probably not best practice. So as your team grows, it can get really dangerous and scary. So instead, look at things like Terraform Enterprise or build your own Terraform pipeline. So how does GitOps look in the practice of using Terraform in your day-to-day? First, you make a branch, propose a feature, submit a merge request, an alert goes out to your team and your chat ops, your chat tool of choice, whatever it may be, Microsoft Teams, Slack, Skype, I don't know if Skype, yeah. Yeah. There's a boo. It's Microsoft Teams. Meanwhile, in the background, while this is all going on, a Jenkins job kicked off. That Terraform plan that ran earlier, it's automated now, right? It's audited, tested, and you can enforce a style guide. You can say, hey, I don't like the syntax. We as a company do 4 spaces, right? Or tab. And again, I'm not going to have that battle. You all can fight that on your own. But in the background, then you get an automated reply. You don't have to action on that pull request until you get a response, right? So back to the operator. Literally, you go into the UI, you say, okay, yep, this looks good, and you click the OK button. When you click that OK button to merge, it goes back onto the master branch, sends an alert saying that the change happened, and ultimately kicks off a Jenkins job to do that change for you. Terraform runs, gets the state file from a remote state. Again, that's one of the ways to solve this. And ultimately locks state. Something that I didn't mention earlier, Terraform, when I said the local state file, 9 people have different copies, you can use the concepts of something called remote state, being that it's a single state file in an S3 bucket, and the way that changes are done, they're essentially queued behind this lock file that's tracked in DynamoDB. So if I try to hit Terraform apply while the pipeline is running, it's locked. It'll say error, locked pipeline, can't promote changes. So that was a quick run through to Terraform and infrastructure as code, right? Moving up the stack earlier, right? Now we have our CI pipelines. There's a lot of tools out there to continuously build code. What do you want to pick? I don't know. There's Jenkins, GitLab CI, Travis, Circle CI. I like Jenkins. It's the old dog of the crew, but it works. It has so many plugins, and it's some of its downfalls too, though. So anyone who operates Jenkins knows this. Jenkins is great. Jenkins is awesome. Jenkins has a lot of options, but as people know, you have to click a button, create the job, and fill in potentially 50 to 70 fields where maybe you only care about 3 things. All right, you did it once, right? You made this change. You're gonna do it again because the developer 2 came to you and said they need a Jenkins job. You're gonna do it again because developer 3 came to you. And again, right? Do you really want to be in the business of making Jenkins jobs every day and then tracking changes across those? No, not at all, right? A great quote is 10 minutes wasted a day is a week a year, right? While you can very well keep your configuration and do your Jenkins jobs maybe 10 minutes a day, you add that up, that adds to a week. That's a release. That's a feature that it could have gone out the door. That's a vacation, right? So the model I presented earlier, it works. Obviously, you can make your Jenkins jobs manually. There's nothing wrong with it. It's a great way to get started. But ask yourself, the time to create those jobs, it's manual. You have to manually update those jobs, and I hope you remember what was configured in the last time you went in that UI. If Jenkins was to go away and you lost all your configurations, how do you create those 100 Jenkins jobs that were gone? Are they defined anywhere? Do you remember how you built that Jenkins job 2 years ago for that one Android project that just no one ever touched? Right? Exactly. So ultimately, at the end of the day, they're not observable. What fixed it? What broke the job? In short, your Jenkins jobs became unique, they're difficult to repeat, and the changes aren't visible, and they're not portable. All right, I think you're seeing the trend. GitOps and Jenkins, how can we solve this? In Jenkins, there's a concept of the Jenkins file. I like to use the job DSL plugin in addition to that is because it's scriptable in Groovy. Whether you hate Groovy or like Groovy, doesn't matter. Again, I don't care. It's just a nice way of defining your Jenkins jobs. Right there, I just defined 2 Jenkins jobs that'll pull a source repository and run like Maven clean and test and some other command. Right? That's 2 Jenkins jobs. Done. It's stored in Git. I can run that anytime I want and recreate those jobs. Not a problem. Helper methods for common configurations, and I'll get to that in a second. You can set up a Jenkins job to continuously pull this file and run it every hour to make sure that the Jenkins jobs don't ever drift and they're always up to date. And then ultimately, you can also reference onto the DSLs, and I'll touch on that in a second too. It's a great tool, but it has a lot of library configurations. And if I was to give this to a developer, not saying that they can't learn it, Do they want to learn it? Is this going to improve their function? Probably not. They don't care that the API for configure steps has changed in this release of the Jenkins plugin versus the other, right? So that's where I mentioned writing an external library, where you can reference an external library that makes changes in the developer's file. It ultimately simplifies their workflow because then they're interfacing with a common standard API that you define and can keep very well versioned for the internal stuff of your company or wherever you are. And on top of it, there are things that are embedded into Jenkins jobs that are potentially changing. Git URL. Hey, today we're using github.com. Wait a second, the VP signed a contract and now we're using GitLab. Wait a second, oh, that's 150 jobs I have to go in and change and update the SSH key. Whew. Okay, credential hashes. Passwords need to be rotated, especially in this world. And other standard parameters and requirements, whatever custom tooling. By writing a wrapper library that the developers interface with, you're on the hook for making sure that things are updated automatically. And ultimately, you can expose this to developers and have them deliver features. Some of the best developers I've worked with have added features to this core library as well, because there are things that they do as well in their Jenkins job that are great. So again, share the love. So how does this work? Again, how does this look? Basically, store your DSLs in a Git repository, and you create a pre-receive hook. Git, if you have the ability to run GitLab or something on-prem, you can install a pre-receive hook, but there's other strategies. And then basically just enable a way to consistently pull. Create a Jenkins job to go to that repository, hit run, and every hour it does something. When that change is detected, the pre-receive hook gets a change and calls Jenkins, and ultimately hits that wrapper library and reruns the Jenkins jobs. And that can create as many Jenkins jobs as it needs, as many as you define in your process, right? And the one earlier I defined, I created 2. Again, why is this great? It's audited. You know when those Jenkins jobs got updated. You have the safe defaults because you can override in the library. And you can also enforce requirements as well too. You can say like, hey, you must use this version of Node if that's something you're required. Or you must not run roots in your Jenkins jobs, right? You could do all this kind of scraping because you have Groovy available to you, again, better or worse, to scrape and modify and remove things. All right, well, I think why everyone's here, CD. What is CD? GitOps and CD, continuous delivery. Again, the CD space today is changing a lot. There's things like Spinnaker, there's Jenkins X, there's Tecton from Google, and there's also Weaveworks. Again, bias in the shirt. I like Spinnaker a lot, so we'll be talking about Spinnaker today. So this is great, but I don't think a lot of you may have seen Spinnaker, so I'm going to give a quick demo of what Spinnaker looks like, how it operates, and let's hope to the demo guys that Wi-Fi works here. Let's see. So I'm going to mirror my displays. Good. So far, so good. All right, so I'm a developer working on a backend project, and I made a change called app.py, and I added git diff, hard to read, but I basically added an exclamation point to hello Belgrade friends. I'm going to git commit -av, said hello to an awesome city. Git push. Committed my code, let's go up to source control. Great, Wi-Fi so far so good, I like this. I'm gonna hit build now. I have a poller, but it polls every 5 minutes, so for the sake of time, I'm just gonna hit the build now button myself. On the other side, I got a prompt. Let's hope this actually, let's see what wins, the build job or me? Okay, so Jenkins, pulling code, building code, not really remarkable, so I'll just let that kind of run in the background. First off, I do want to show that we have our service up to date, and it's saying hello world, right? Not what I committed. But within Spinnaker, should have hit this before. Demo gods are still on my side. I deployed my code earlier, about 4 hours ago. For the sake of time, I also made the same commit on the Jenkins job here. Let me see if the job kicked off yet. Rebuild last. But this commit's essentially the same. I'm just going to go ahead and first thing it did was baked my code. It did whatever it needed to do to create a version of my package. A developer then just has to say, do you want to deploy this? Yes or no? I'm going to say yes. I'm going to hit the continue button. Demo guys are still on my side. First thing it does, stage infrastructure. It's going to go out to the repository and create the load balancer, create the firewall, create the DNS record, create the instance profile and the IAM role. And we're talking Amazon here. But if this was Kubernetes, it would go ahead and provision any services or pods or anything that, or update any configurations outside of the world. It's kicking off a Jenkins job, still running. Console outputs, okay, a lot of data, so far so good, it looks right. And okay, cool. It's actually getting to the deploy phase. So right now, it's actually going ahead and take that code and deploying it out to the world, making it live. This takes about maybe a few minutes, so I'm going to get back to the slides and I'll come back once this deployment's done. But hopefully this URL, me presenting, you got to click on that, will show hello Belgrade or hello friends. So let me get back to these slides. Display. Mirror displays. Oh, crud. You know what? This is what I'll do. Where'd it go? Boom. All right, we're back in action. So what I didn't show you is to configure those pipelines. Very similar to Jenkins. A lot of steps, a lot of abilities. There's a lot of options there. So many options, you can create pipelines that look like this. A lot of steps. I think there's about 72 steps in that image right there. As I alluded to earlier, do that again. 72 steps. Do that again. 72 steps. Do that again. 72 steps. Just one more time, please, Joel. Just one more time. I just need my pipeline. One more time. It doesn't scale. Trust me, it won't. So you got to find a way to automate creating these Spinnaker pipelines. Otherwise, you will go nuts. So a little bit about what a Spinnaker pipeline is. As impressive as it is, there's a lot of dots, green flashes, buttons that are okay. It's a lot of heavy lifting things that go in the background. There's a whole task engine. And if you haven't heard of the project, you should check it out. It's spinnaker.io. But at its core, a Spinnaker pipeline is just a collection of JSON. So JSON can be scripted. There's a lot of templating languages out there to make JSON repeatable, right? The best part is that it's comprehensive and it's very well defined. And that's what makes Spinnaker pretty great in my opinion. So out there's a few solutions. There's the managed pipeline templates that are in V2 right now by Spinnaker's community. There's another tool out there from Armory, great folks. They provide an enterprise offering with Armory, with Spinnaker. It's called Dingy. But the one that I personally still have a lot of attribution to, because I helped open source it, is a tool called Formast. So we're talking about Spinnaker and Formast. I think you guys got it's the things that I like. So what is Formast? At its core, it eliminates the need to have to recreate those pipelines in the UI because you can define them in code. It enables the ability to reproduce Spinnaker pipelines. Again, if someone hits the delete button, okay, no problem. Hit rebuild, you're back online. It gives the ability to standardize pipelines with safe defaults. That pipeline JSON was massive. I don't know about you, but I would not trust myself to manually edit this, nor would I give this to a developer to say what ref means versus job means, right? You can kind of override some of the things in that pipeline. Again, make it easy for the developers to progress and just focus on code. So how does this work? How does Formast kind of work? What does it make? What's the advantages of it? So as a DevOps team, we have a collection of base templates where we define all the different infrastructure pieces, like security group, or pipeline stages.json. This is a common thing. We use a tool called Jinja2. It's a Python library. It's a pretty nice one too. you basically define, if this, else that, whatever you need to include JSON blocks. So let's take a look into this one. What does this look like? Very similar. If you kind of saw in that screenshot where the lines were scrolling, we just literally take the actual JSON and add template values. For example, instead of hard coding the environment, you say data.app_environment. And that goes into the nested structure and replaces the values. So that's great from a DevOps perspective, but usually that repo isn't touched too much by developers. There's sometimes suggestions and ideas and meetings where you could plan that, but really what does a developer's workflow look in this system? They have source code, I hope, as a developer, so they write code. And they have a concept of a runway where you have your DSL Groovy. I alluded that's your Jenkins job. And a collection of files, a pipeline.json, which specifies, hey, what do I need in my pipeline? What environments do I need? So let's say for this one, I need stage and production. So no problem. I define 2 files, stage and prod, and now I have these 3 files for formats. How do these files look? It's pretty simple. You just find a name. I called mine base example Fedora. That could have been foobar. It could have been, front end service, whatever you want. Do you want any notifications? What Slack channel do you want? Put it in there. Deployment Spinnaker is, again, because when we open source this, it targeted both Asgard and Spinnaker, but it's kind of some legacy stuff. That's the reason why that exists. But mainly the thing is stage prod. I want it in my app in stage, and I want my app in production. Here's my email, and ultimately I want Chaos Monkey enabled. If you don't know what Chaos Monkey is, you should look it up too. It's a fun way of doing chaos engineering. We are looking into doing different ways of doing that at Redbox as well. It's a fun way to make sure that what you are writing is highly available and resilient. So for example, I'm going to propose a change. I'm going to change the Slack channel from change me, obviously, to deployments. I want every time something happens in this pipeline to go to the deployments channel. Pretty common. I propose that change. I make a change in Git, a pre-receive hook, as I mentioned earlier, saw that, hey, pipeline.json changed. I'm going to send a notice out to Jenkins, which is going to then pull in the base templates with the actual big blob of JSON plus the small layer of JSON and stitch the worlds together, fill in the blanks, right? And that's basically it. It then creates a JSON blob that you can post to the API of Spinnaker. The beauty of it is, again, it's auditable. You have safe defaults. You can do overrides, so developers can't do M5X large servers in dev. Maybe you can, but that's, crazy. And you can enforce requirements. Hey, I want to open up port 22 to the world. No, probably not. Right? You want to lock that stuff down. So this then runs a command called prepare app pipeline, which then hits Gates API. We also support authentication into Gate as well if you have an authenticated endpoint within Spinnaker. And it creates your changes. So I touched on it earlier, but Spinnaker gives you the ability to making staged infrastructure changes. So again, I mentioned at Redbox, we give developers freedom to define what they need when they need it. So developers are able to define, first off, let's say we have a security group. We define things, this is kind of how the examples look. But developers are able to define things like, what regions do you want your code to go to? What is the load balancer port? Do you need an SSL certificate? What size instance do you want? Description, any firewall changes you may need. Again, it's all defined in one file, but it gives developers that freedom of making those changes. That change is committed to the repository, the infrastructure change, same story. You make that change, it goes to the Spinnaker API because it's in source control. So I showed this earlier too. This is one of the more complex pipelines, but basically listens to a change in Jenkins, triggers a bake, does infrastructure, maybe some Git tagging, deploys to dev, and you can do things like quality steps, targeting, tagging dev as well, so you know when your change actually went out to the world, and potentially do scaling policies. So this one runs at that stage right there, infrastructure stage, pulls the source code down, prepares infrastructure, and creates any resources you need. So again, that define change, you define it. When that bubble gets to there, Formas runs, pulls the source code down, looks at the differences, and makes any modification. It does it in upsert fashion, so there's no shifting of the planet underneath for customers. The next one is it tags back to the Git repository. And it's great because at the end of the day, it's just, again, it's auditable. It's tracking the changes with tags. It's a good process because then you're able to say, when was this commit made back to dev? When did this commit make it to dev? Well, at 6:51, Spinnaker ran and promoted this change to development environment. Formas also has Lambda support. It has support for S3 buckets. And ultimately, it empowers auditability and traceability. So we've used Spinnaker to meet SOX and PCI level 1 compliance, which is arguably the biggest, could be the biggest blocker when talking about automation, right? And we're able to maintain fast deployment speeds. We don't have change review. We don't have a body of people saying, all right, what are the 50 changes coming out this week? Yep, looks good. Because most of the time, there's no way to know exactly what those changes are. Running slower at that pace could actually be more harmful because you don't know what change may have been in that list. You know, developers may have moved on from that feature. They may have developed that feature 2 weeks ago. And here we are reviewing the change 2 weeks from that day of the commit being out there. So some things to consider when doing Spinnaker for compliance. Again, running fast, you have to be careful. You have to make searchable records of your deployment, right? Give an auditor or someone to know when things are changing. Make it so a single developer can't deploy to prod, but maybe make it so another developer on the team has to approve the changes. So Joel made the change. Jennifer has to click the button to see why, I approve, that's a good change. Yes, you're changing the environment, whatever. It's a separation of duties. That's really what auditors mostly care about. So you can't just steal a penny from every transaction or something, or buy Bitcoin or something in the background. And another one is block pipeline changes. So another thing you'll probably get is, hey, someone's making a change in the pipeline. Just lock that pipeline so people can't change it outside of your process. So one of them, a developer can't approve their own change. Just add an audit approval step that just checks that the person who hit the OK button is different than the person who's actually wrote the code. It's just kind of an audit step there before you actually do any changes. Automated change requests. There's nothing wrong with tracking state. In fact, it's probably better. For example, at Redbox, we just create a Jira ticket every time a deploy happens. Even in staging, it's not Jira has an API, write a small little Python script and just dump data into it. You're able to go back and view source control. You're able to view that. You're basically, every time you deploy, you're even able to go back to the commit and see the change that it was actually hit OK on. And I'll probably hopefully show this here too. And it really just doesn't slow anything down. Another thing, as I mentioned earlier, make an audit database. You can just create like a simple web GUI, store all the deployments in there, and just say, here you go, so-and-so audit body. Go to this website, log in with your credentials, and you'll be able to see stage change. Here's a Git commit. Here's who clicked OK. You basically have everything tracked, and just use that as kind of your central source of truth. All right. So where are we going from here? Right. This is kind of the story of where we're at. And if the giant ship wheel does not allude to it, we're looking at Kubernetes at Redbox. So what does this mean? How does this look? So why we're doing this, we're looking to build a new TV experience. Some of the great stuff there, .NET Core, Docker and Kubernetes, right, Google Cloud, and Amazon. And some great things. We're also doing some great initiatives on the data side too with Apache Spark, using Elasticsearch, and much more. So really trying to revitalize everything. Deployment velocity, something to look at is this is actually, it's kind of really interesting because I'm giving this talk after I initially gave this talk of my arrival at Redbox. So I kind of see before Spinnaker and after Spinnaker. So if you kind of see this trend, January is like, oh, is this really going to work? February is like, okay, it's looking a little bit better. April, for some reason, skyrocketed. The last one is actually May. And you're probably wondering, wow, that's lower, so is something wrong? It's still May 15th, and we almost are on track to potentially double our deployments, which is awesome. So again, these are all developer driven. There's no change control. Developers are driving the changes, rolling back their own code. They are empowered to make the change, deliver the features, and ultimately at the end of the day, developers are talking about how to build that code in a way that best services our customer. So we picked Kubernetes for a few reasons. A lot of folks kind of wonder, like, well, what's the big deal of Kubernetes? Why Kubernetes? I have my data center. I have this. I could just create more servers. We run an immutable infrastructure. So with that, we also run containers. We're able to have immutable container workloads. Makes sense. It's great. I don't no longer have to patch my base operating systems. I don't know about you, but after all these Intel scares of servers being compromised, companies around the world are talking about how to patch their 1,000 servers. It was cool a few years ago. It's no longer cool today. I want to make sure that I'm running on the most secure, most highly available infrastructure. Right? So that's the biggest thing. It's declarative. A lot of things that Formas did, the reason why Formas was created was because there was no single way to automate your end-to-end architecture in a file. Kubernetes does that for you. It gives you a deployment file. If you're familiar, I'll show you some examples of it. And you can also auto-scale. You need 10 servers or 10 nodes to handle traffic. Oh no, it's holiday season. We need 30. No problem. One command, you're at 30. Assuming you have the resources. So what I mean by declarative, nothing can go into Kubernetes unless it's defined, right? What labels do you want? Labels are just metadata. So what's in there, the name of the application, what version is it, labels. How many pods? I want 3 replicas of it. So every time I deploy, I want 3 servers to handle traffic. What container image? This is just a small one, but at the bottom there it's saying use Nginx, version 1.79, right? And ultimately, what port? Again, everything that you see here kind of looks a lot like the Formas pipeline stuff because, again, it's all defined. That's the biggest thing. It's defining everything in a Git repository. So when you make those changes and when you commit those changes can occur out to the world. Kubernetes has horizontal scaling. Again, I alluded to it earlier, but you can issue a command, gets metrics. It basically can continuously evaluate your cluster based on those metrics. Say you want to scale up to 6 nodes when your cluster hits 50% utilization. So one line command, it's saved, you're good to go. If you're using Google Cloud, you have the ability to scale vertically. So those are for more stateful workloads. In the event that you're running something like SAP, you can't just kill an SAP server and expect to be back up in 10 minutes. You most likely have to scale vertically and figure out what your resources are, things are. Again, another Google Cloud feature is, as I mentioned earlier, Kubernetes is great, but it's also limited by finite resources. If you only have 100 gigs of RAM dedicated for your cluster and let's say 300 gigs of storage, when you're at 300 gigs of storage, you're at 300 gigs of storage. Kubernetes is not just going to say let me just spin up more servers for you, unless you're in Google Cloud. It gives you the ability of saying, hey, I'm kind of at this load. I'm going to go add more servers to it behind the scenes. Another advantage as to why we're looking at Kubernetes mainly is Istio. Istio is a service mesh that basically allows you to abstract away kind of your routing, your security, and your observability of your application stack. It has security built in. Commonly when talking about service-to-service architecture, some of the things you have to consider is, well, how does service A talk to service B securely? Well, before, you provision self-signed certs, you put them on the server, you boot up Tomcat or whatever process you may have. Well, guess what? You have to rotate that certificate. Oh, crap. Okay, so I'll go ahead and do a patch, roll out those certificates. How are we going to do routing? Ultimately, how am I going to make sure that those pods can talk to one another, those containers can talk to one another? I don't want just everyone to be able to talk to one another. That's wrong. Even within your own concept of your data center, you probably want a rate limit within there. Within Kubernetes, within Istio, you're also able to set in between apps policies as well to rate limit. It also does native MTLS in between the 2 nodes and various other things too. It's great. If you haven't seen it, it's pretty good. You're able to define common routing rules. It looks like it cut off some of the bit there. But you're able to say that, hey, everyone in the world gets V1 unless your username Joel Vasalo. In which case, this policy here denotes that it's going to look for a header that's called username, which exactly matches Joe Vasalo. There's ways of doing regex and stuff like that too. And if it matches that, send it to V2. Otherwise, go to V1. That simple policy can be defined. It can be GitOps as well. And those changes can be rolled out to the field. It's a great way because you can do things like canary analysis, A/B testing, testing in prod. Testing in prod, which is like, you hear that and you're like, oh no, that's a bad thing, right? So it could, yeah, it's pretty cool. It also allows you to do things like Jaeger for tracing. You're able to do deep analysis of your API calls as well. So you're able to see things like, hey, something broke. It was working a second ago. Well, the driver for Redis just failed because of a timeout, right? You're able to visualize that entire stack trace of your code without having to scroll and scroll and scroll, and you're like, oh, wait a second, AWS API call failed because something, 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 right? Visualizing those errors provides a lot of value, but not only visualizing your errors, visualizing your call flow. That's awesome. How is my front end working? Well, it looks like it calls a driver, which calls Redis, and then I have an app called customer, which calls back to MySQL. Now you have your dependencies of how things are connected, and ultimately the connections that are flowing in between those nodes. Awesome. Observability. And again, Spinnaker loves Kubernetes. For those of you who may not know, part of the Google Cloud team helped support and build Kubernetes support within Spinnaker. So those manifest files that we were alluding to earlier have direct support. They also added features for like automated canary analysis, so you can evaluate deployments and stuff like that. But again, the flow is very common as to I've been talking about this whole evening. Developers commit code. Some repository then triggers a build, or well, the Jenkins listens for a build, pushes it to a registry, Spinnaker sees it, and deploys that change out to the world, based on whatever business pipeline you may have. So, kind of to recap, we've been talking now for almost an hour. The thing that I like about Spinnaker is, the beauty of Spinnaker is its flexibility. You can define pipelines that make sense for you and your business, right? I could have easily allowed production deployments without any audit approval, right? I could have easily said, hey, when a change in Git happens, make this change go out. No matter how you use it, we're all going to set sail together in this Spinnaker community. So some of the key concepts: leverage Git as your single source of truth. If you think it's going to be changing, put it in Git. Don't put your secrets in Git. If it can be described and declared, it can be automated. GitOps is not a tool; it's a practice. You have to practice the concepts of thinking about things that make change in your infrastructure and putting them into Git repositories. Part of this is empower your developers to make those changes, but make it simple so they don't have to context switch, right? Again, not because they can't understand it, it's because they shouldn't need to understand it, right? Find what works best for you and your business. I gave 3 examples today, but there's many of them. And the last one I hope folks saw was Spinnaker gives you a way to make some great solutions. You can make very customized pipelines. And with that, I'll say thank you everybody for letting me speak here in Belgrade. There's my Twitter and my website if you're interested. At Redbox, we're doing some great things. So we actually created a tech blog and we're sharing articles. Developers are encouraged to write there too. And then ultimately, InterVenture is a great company that we're really partnering with to deliver some awesome things. So we're really happy to be working with them, making some great stuff here in Belgrade too. So with that, thank you so much everybody for letting me speak here. Let's see if my change actually made it to prod. Okay. Hello world. Hello Belgrade friends.